In this video, we're going to talk about the right triangle composition, okay? So sometimes you will get an angle which is not a unit circle and you have no idea what is that equals to. In that case, you're going to use the right triangle, meaning you're going to draw the right triangle on the proper quadrants to figure out the ratio or evaluate the compositions like today, okay? So you got to remember before we get started, the SOHCAHTOA that you talked about in geometry class. Again, sine equals to opposite over hypotenuse, cosine equals to adjacent over hypotenuse, tangent equals to opposite over adjacent, but on top of that, you have to know the cosecant, secant, and cotangent as well. Remember, the cosine is the reciprocal of the sine, so that equals to hypotenuse over opposite, and secant is reciprocal of the cosine, so hypotenuse over adjacent, and cotangent, that is the reciprocal of the tangent, so adjacent over opposite. Okay, you have to remember this. Now, let's review the definition of the compositions as well. So remember, we talked about this last semester, but also in Algebra 2. When you evaluate the function compositions, you have to start with the inner function and apply that value to the outer function, okay? So if you look at the first example right here, I have to evaluate the cosine of arctan of 12 over 5, okay? If you think about the unit circle, okay, none of those angles that we filled out will give you the ratio of tangent ratio of 12 over 5, okay? So this is the angle. I'm dealing with the angle that I don't even know what that is equals to. So in this case, you have to draw the right triangle, okay? So arctan, remember yesterday we talked about it and the day before, it has to be either in the first quadrant or the fourth quadrant, okay? It has to be between pi over 2 and negative pi over 2, okay? But since this is positive, your right triangle has to be on the first quadrant. So I don't know what this angle. By the way, this arctan meaning tangent of some angle theta equals to 12 over 5. So my angle theta has to be in the first quadrant, okay? And tangent equals to opposite over adjacent, or opposite side of this opposite side of this triangle is 12 and adjacent is 5. Now, that's it for the inner function. You're not trying to find the exact value of this angle, but you're just trying to figure out how the triangles looks like, okay? So for the outer function is cosine, right? So in this case, you're dealing with the same angle and the same triangle that you figure out the first step, okay? So it's asking, what is the cosine of this angle right here? Okay. Remember, cosine is adjacent over hypotenuse. Okay, so I know the adjacent of this triangle, this angle is 5, but I don't know the hypotenuse, meaning you have to find the hypotenuse. Now, what is that equals to? How can you find it? Remember, this is the right triangle. For the right triangle, the one of your favorite theorem that you learn is the Pythagorean theorem, right? So you're going to use that. Remember, Pythagorean theorem equals to a squared plus b squared equals to c squared. So in this case, 5 squared plus 105 squared equals to c squared, which is hypotenuse squared. So that equals to 169 equals to c squared. Then if you take the square roots, you'll get 13 equals to c. So your hypotenuse is 13, meaning cosine of this theta equals to 5 over 13. And that's all you have to do for this. Now, second example here, same thing. Let's talk about the inner function first. Arcsine of 3 over 5. I don't know the angle, but sine of that angle has to be equals to 3 over 5, okay? Those angle, I know sine is positive in the first and the second, but your inverse has to be the first and the fourth quadrant. And since this is positive, your triangle, your angle has to be in the first quadrant. So here's the angle. And again, I don't know the exact value, but your opposite is 3, hypotenuse 5, okay? And outer function, I want to find the secant of this angle right here that I don't know what that is. And secant equals to 1 over cosine, which is the reciprocal of the cosine. So that is hypotenuse over adjacent. Okay, I know the hypotenuse value is 5, but I don't know the adjacent value. So again, you're going to use your Pythagorean theorem. So 5 squared equals to 3 squared plus b squared. 25 minus 9 equals to b squared. So 16 equals to b squared, meaning your b value equals to 4. So your adjacent is 4, meaning secant of same data equals to 5 over 4. Okay. And the next example here, evaluate the cotangent of arc cosine of negative 8 over 17. Okay, again, I'm going to do the inside function first, inner function, okay? This means cosine of some angle equals to negative 8 over 17. But remember, your inverse cosine is in the first or the second quadrant, okay? Your angle is between 0 to pi. But your value, the ratio is negative here, meaning it has to be on the second quadrant. Your angle has to be on the second quadrant in this case. Okay. And cosine is adjacent over hypotenuse. So adjacent side is 8 and hypotenuse is 17. But this is negative, so which value has to be negative? Is adjacent or hypotenuse? The one thing that you should remember is that your hypotenuse, the h value, is never negative, okay? And also in the second quadrant, your x value is negative, so you're gonna add the negative sign to the adjacent, okay? And I'm gonna find the cotangent of the same angle there. Remember, cotangent is the reciprocal of the tangent, so adjacent over opposite. In this case, adjacent is negative 8, but I don't know the opposite, okay? So to find the opposite again, I'm going to use the Pythagorean theorem. So a squared plus negative 8 squared equals to 17 squared, which is a squared plus 64 equals to 289. Then a squared equals to 225, so a equals to 15. So in this case, your hypotenuse is 15, so cotangent of the theta, the angle is negative 8 over 15. The last example here is sine of tangent, arctangent of negative 5 over 7. Okay. The same thing, inner function first. So tangent of some angle is negative 5 over 7, okay? But remember, your inverse tan has to be on the first or the fourth quadrant. But again, since this is a negative, instead of being the first quadrant, it has to be on the second quadrant, your angle, okay? And from here, opposite is 5, adjacent is 7. But in this case, which ones gets the negative sign? Okay. Be careful in the fourth quadrant. Your y value is negative, meaning in this case, your opposite side gets the negative sign. Okay. So sine of same angle that I have right here, that equals to opposite over hypotenuse. Opposite is negative 5, but I don't know the hypotenuse, so again, you're going to use the Pythagorean theorem. So in this case, c squared equals to 7 squared plus negative 5 squared. C squared equals to 49 plus 25. C squared equals to 74. Unfortunately, 74 is not a perfect square, so if you take the square root, you will get square root of 74. Okay. So you're going to put the square root of 74 for the hypotenuse. Okay. We talked about the rationalization, so if you want, you can rationalize this, meaning you're going to multiply this by square root of 74 over square root of 74 to make negative 5 square root of 74 over 74. Okay, rationalizing is up to you, it's your preference, but then your sign of theta should be negative 5 over square root of 74 or negative 5 times square root of 74 over 74.